Blasting playpen in the daytime, goosebumps rise at 9 and settle back down at sunrise. Cut the cord at noon and say you'll be back soon. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. It's some booze-fueled teenage ground, running from pub to club like bloodhounds, from 10 till 6 a.m. and no one knows how to stop them. Hold the drinks out one and help the one who's gone. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. Let's get girly. Let's get girly. With a hangover till 10 p.m. I'll say I'll never go again. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. Tut-tut, no worries, please get back early. Head out with champagne and dresses and let's get girly. Let's get girly. Let's get girly.
Hi guys, it's me again, Cecilia Tale, the lead coach and the BIM strategist behind the BIM Process Learning and Migration Program. And as I said, I aim to push the industry forward with BIM. Honestly, right now, I'm not feeling very well, so you may notice a bit of hoarse, manly voice because my throat hurts. But I will still try my best to teach you what I can today. Anyway, welcome once again to our BIM process introduction course. In our first lesson, you learned about what exactly BIM is and the new technology that makes it work and why you need to know about it. And in our second lesson, we talked more about how BIM is making an impact on the industry, why you need to upgrade yourself constantly so you don't get obsolete, and the new specializations you can pursue after you learn BIM. And if you're not able to watch those two lessons, I have a link down below to the course page where you can access it and where you can finish the course. And if you finish the course, you can instantly get your certificate. So definitely click on that and view the other lessons. And if you're really ready to give yourself that boost in your profession, then this is the place to be because today I will be starting you off with the basic BIM things that you need to know about how things work in BIM. We are now on our third lesson and we are now on the topic of the BIM process itself. We will now be talking about the standards around BIM, the softwares, and near the end of our lesson, I'll be showing you the bonus video, a simple project done using my favorite BIM software, so you'll see the basic functionalities of BIM. And in the last sessions, you found out about the importance and the impact of BIM in the industry, in the country, in your career, and you also learned about how you can excel and continue advancing in this industry. Now, one of the things I want to help you achieve today is a clear understanding of how BIM works and to really prepare you to take the next step. I'm gonna be showing you a small project using BIM. So before we start, I want to thank you all for emailing me with your concerns, struggles, dreams, and I also want to thank you for chiming in on our discussions. But I know this that one of the biggest concerns often being mentioned in the emails was the fear that you won't get a job in BIM since there's not many local firms here that use BIM. But the thing is, there may not be local firms that use BIM, but there are tons of offshore foreign firms in here and outsourcing firms that hire BIM specialists. And a lot of local firms also partnered up with foreign firms and they also need BIM specialists. Actually, personally, I've been asked too many times this week by my industry connections if I have some of my previous students or connections, I can refer to them since they're having a hard time hiring. The demand is high because the supply is so low and the companies are slowly realizing that they need BIM. So the demand is getting higher and higher. And there are many roles available for you for the taking locally. And you can also go abroad faster because BIM specialists are in high demand abroad. Plus, you can also be freelance BIM specialist if you're into home-based work. Now, so you'd understand that better. Let me show you what I'm saying. Let's visit some of the job search sites where you can see these listings. Okay, for example, we have JobStreet here. Okay, so what I did is I just typed in BIM for the search criteria and all these jobs appeared. Now, uh, these salaries are not green for me because my expected salary here is I think around 70,000. I can't remember. It's been a couple of years since I last looked for a job. Anyway, so that's basically it. For example, we have here facade designer for Revit or BIM, which basically this one falls under the BIM technician category. So if you can see, you can earn from 40 to 45,000 pesos. And we also have other job openings here. For example, for this one, you have BIM modeler, BIM coordinator. BIM Design Engineer, for 3D BIM Modeler, BIM Manager. You can also search here, say Revit, because basically Revit is one of the most used BIM software here in our country. So, for example, there, I got 150 jobs just for Revit. So let's go to another job search site. Let's see, for Indeed. It's the same. So I got 138 jobs lists for the BIM position. So there's not really a lack in BIM job here in the Philippines. So let's see Australia. Okay. For everyone who wants to go to Australia or to other countries, okay. So they also have lots of opening for BIM, and it's really very much in demand in other countries. So for example, for this one, you can be a BIM coordinator, which basically falls under BIM experts, and earn 110 to $140,000 per year. And you can also be a BIM manager, project manager, BIM coordinator. So uh, there, I just proved to you that there's no lack of job opportunities in BIM. It just all that matters is you're confident enough to try it out. And you know the trick to getting jobs is just really to be confident. And I already showed you in the first lessons how to get that confidence that can help you land the best jobs. So you have to take action, upgrade your skills, learn, and learn some more, and get the best jobs in the market by having your confidence boosted by so much understanding that you just learned. And if you're confident enough, you'll be able to ask for the salary you want. So let's start you off with learning. Today, we'll talk about the standards that make BIM work. First, let's talk about BIM maturity levels. The concept of BIM maturity levels has become the accepted definition of what the criteria required to be deemed BIM compliant, by seeing the adoption process as the next steps in a journey that has taken the industry from drawing board to computer and ultimately into the digital age. But what are the levels and what do they mean? There are 4 levels of measuring BIM: 0 to 3. The maturity levels are the construction chain's ability to operate and exchange information. For example, you have level 0, which is basically low collaboration. It's basically the unmanaged computer-aided design, including 2D drawings and text with paper-based or electronic exchange of information, but without the common standards and processes. Essentially, this is just a digital drawing board. Then we have level 1, which is the partial collaboration. Level 1 is a mix of 2D and 3D information. For example, if you have, say, CAD and then you're using 3D CAD or SketchUp for your 3D. It's also known as the managed CAD. This may include 2D information and 3D information, such as visualizations or concept development models. Level 1 can be described as the lonely BIM, as the models are not shared between project team members. Then we have level 2. Level 2 BIM is basically full collaboration. Uh, it's so widely known as the mandated level. It is also what we call the collaborative BIM level, a managed 3D environment with data attached but created in separate discipline-based models. And these separate models are assembled to form a federated model but do not lose their integrity or identity. And the data may include construction sequencing and cost information, which is 4D and 5D, as we've discussed in our last lessons. Well, and the design information is shared through a common file format, which enables any organization to combine that data with their own in order to make a federated BIM model that's used for coordination and project communication. So this level of BIM may utilize 4D construction sequencing or 5D cost information. And the 3D models with the project data are shared using a common file type. So usually that is IFC. Another important, oh, sorry, I forgot to mention level 3. Oh, sorry. Anyway, for BIM level 3, we have the full integration, or what we could call IBIM. BIM level 3 is the goal for the construction industry, and its main point is the attainment of full integration of information in the cloud-based environment. A single collaborative online project model with construction sequencing, cost information, and project lifecycle information. So it has all the dimensions of BIM, and this is sometimes referred to as IBIM or integrated BIM, and is intended to deliver better business outcomes because of the uh, connection, the collaboration, the type of collaboration that will be implemented. Now, another important aspect of BIM we should talk about is the LOD. It can mean two different things, but it's basically the levels of refinement used as a measure of service level required in BIM modeling. And when talking about graphical representation of an object, you're basically just discussing the level of detail. And when discussing both the graphical representation and the information properties of the object, you're now talking about level of development. For the level of details, it follows three different standards, and you may be familiar with this if you're familiar with CAD. So we have the AEC UK BIM protocol, the CIC, and the USA CEM3. Each one signifies a different grading for the level of detail, but commonly we use the AEC BIM protocol for the CAD detailing. So let's talk more about that. So the different levels of the AEC BIM protocol are the G0, G1, G2, and G3. For G0, it usually just says schematics. It's a symbolic placeholder representing an object which may not be to scale or have any dimensional values. So this is particularly relevant to electrical symbols which may never exist as a 3D object. Then we have G1, which is the concept. It's a simple placeholder with the absolute minimum level of detail to be identifiable. Sorry. For example, it could be any type of chair, a superficial dimension representation created from consistent material, either concept white or concept glazing. So, and then we have G2, which is the defined. So it contains relevant metadata and technical information and is sufficiently modeled to identify type and component materials. Typically, it contains level of 2D detail suitable for the preferred scale and sufficient for most projects. Then we have G3, which is the rendered. G3 is basically identical to G2 version if scheduled by annotation, but it differs by 3D representation. It's used only when the 3D view is at a sufficient scale and it's deemed necessary to be that detailed due to the object's proximity to the camera. So it's basically used for, say, perspectives. So components may appear more than once in the library with different grades, and the naming must reflect this. Now let's move to the level of development. Usually this is the one we really use for BIM, and this specifically measures graphic representation or 2D and 3D plus the amount of embedded information. So LOD, as in level of development, measures the certainty, confidence, and the amount of information which has been implemented in the model. The graphical representation of the object does not necessarily need to develop with LOD, although it usually does, because now the emphasis is on the added information. Therefore, LOD levels for a chair might go, for example, for LOD 100, there is a chair. LOD 200, there's a chair that has a nominal space requirement of 500 by 500. LOD 300, there is a chair with armrests and wheels. LOD 400, the manufacturer and the model number now comes in. And LOD 500, the manufacturer, the model number, the supplier, and the date purchase now comes in, because this is the as-built information, or the information on the actual object. So let's talk more about these. I'll be using a stair sample in the standard LOD specification book to show you how it basically is. So for LOD 100, the model element may be graphically represented in the model with just a symbol or a generic representation, but it does not satisfy the requirements for LOD 200. So information related to the model element can be derived from other model elements. So basically, we also could call this the pre-design. Now for the LOD 200, the model element is graphically represented within the model as a generic system, object, or assembly with approximate quantity, size, shape, location, and orientation. Non-graphic information may or may not also be attached to the model element. So this is what you usually call the schematic design. Then we have LOD 300, where the model element is graphically represented within the model as a specific system, object, or assembly in terms of quantity, size, shape, location, and orientation. So usually with this, non-graphic information is also attached to the model element. So this is usually what we call detailed design. Now for LOD 350, the model element is graphically represented within the model as a specific system, object, or assembly in terms of quantity, size, shape, orientation, and interfaces with other building systems. So usually with LOD 300, non-graphic information is definitely attached. So this is what we usually call the construction drawings. And now we have the LOD 400, where this is where when the model element is graphically represented within the model as a specific system, object, or assembly in terms of quantity, size, shape, location, orientation with detailing, fabrication, assembly, and installation information. So this is what we usually call implementation documents or fabrication documents. And then we have LOD 500, where the model element is a field verified representation in terms of quantity, size, shape, location, and orientation. Take note of the word field verified, because this is what we see as the as-built drawing. So the non-graphic information is definitely embedded in this, and usually includes a lot of the installation data. Now, let's look at the softwares. There's a myriad of softwares in BIM, and honestly, it's not like when you just had CAD where you don't have to choose from so many of them, and it does not make you uh, overwhelmed if you're new to the game. In BIM, you have to keep in mind that different softwares solve different problems. Although some do very specific tasks very good, and some are more multifaceted and have the capability to multitask or answer different problems. So let's go see a list of all of them depending on their main use. Some of these have multiple capabilities, but I've focused on this I focused this list on the software specialty. So first, for our BIM execution planning, this helps the workflow for planning the project execution. So you have here LOD Planner. Next, for content management in BIM, it's not just the lines and geometry. We also have objects or components or families. These can be preloaded with manufacturer data or custom made for the projects. And for that, we need the content management softwares. Although for some, they prefer not to use them and just use the generic models in the softwares, but for larger projects, I advise using them since it gets tricky to handle manually. And also, a lot of these softwares connect you to the manufacturers where you can download BIM components, models for their actual products. So, this makes for more accurate design and specifications. For this, we have Unify, Avail, BIM Object, BIM & Co., and MagicCAD. And now for BIM modeling. These are the main softwares we use for BIM. Although there's one here that's not really fully BIM capable, which is SketchUp. And I don't really advise using this unless it's for schematics because of its limited capability and in embedding information. And the schematic model you're going to come up with SketchUp isn't really usable in other BIM softwares. For example, if you're going to be using Revit, you lose a lot of data or design, so you're just going to have to model it from scratch anyway. So I'd rather just start with Revit than start with SketchUp and go to Revit. Anyway, the others in this area are Revit, BricsCAD, Rhinoceros, Dassault Systems, SolidWorks, ArchiCAD, Katya, Tekla, Allplan, Bentley, and Vectorworks. Now, algorithmic design is basically task automation via scripts. So I talked about this on lesson 1 on the technologies. These applications, though, are usually based on visual scripting rather than the text scripting. And they help automate design workflows and some other tedious tasks. So you have a choice of Edgewise, Hypar, Dassault Systems, Grasshopper, and Dynamo. As for performance analysis softwares, they analyze the design performance of building designs. For this, we have Green Building Studio, SIA, STAD Pro, Sapphira, Robot Structural Analysis, and Ladybug. Now, since building information models are usually created by many stakeholders, and in order for everyone to stay on the same page, these models need to be shared through one collaboration app. So these collaboration tools allow teams to share and access the right models at the right times. So here we have Drofus, Tekla BIMsite, Allplan BIM Plus, Trimble Connect, and BIM 360. Now this next tool is for the BIM validation. When combining 3D models from multiple project teams, you can uncover a lot of issues. So these problems can be solved in the virtual model at a much lower cost compared to after the construction team has started to work on site. So sometimes there are thousands of issues to track, and this is why the following BIM checking workflow tools are essential to gain the true benefits of BIM. For this, we have BIMX, BIM Collab, Solibri, Navisworks, BIM Assure, Revisto, and BIMTrack. Now, for the estimating and scheduling, these workflows is an important benefit of BIM. So model elements can be scheduled over time to identify phasing and sequencing challenges. So elements can also be automatically counted and tied to estimating databases to generate more accurate 5D construction estimates that will update as the model changes. So these are the tools for that. You have Assemble Systems, Deprofiler, CostX, Synchro, Vico Office, and M2. Oh, sorry, I think my face covered all Vico Office and M2. Anyway, after the building project, after building the project virtually in the computer, we now have to go to the construction. We have to break dirt and build the real thing. So this is where rubber meets the road. So many of the collaboration tools previously listed are also used through the construction phases. But the following tools are those focused more on the construction side, the construction and scheduling management side of BIM. So with that, we have Alice Technologies, Grid, Verity, yeah, and Verity. And for this last one, the I in BIM now comes alive, and building information models are transformed to be facility information models, and it can be used for the entire life cycle of a building. So these tools help building owners quickly find important information at the right time to gain efficiencies when operating their built assets, like Onoma, Ecodemus, ViewOps, UBIM, and Archibus. Now, since I know all of this sounds so overwhelming and all, I'd like to talk about my preferred softwares. I use many more softwares depending on the projects, but what I'll show you is the basic software set I use if I'm not required to use other specific softwares. So we have this. For BIM execution planning, of course, I'd like to go with a little help from LOD Planner to help in making the BEP manual, but sometimes I just nail it myself. And as for the content management, I usually go for BIM Object. It's free. They have thousands of downloadable objects, and they also maintain and develop branded BIM products for manufacturers. But whenever I don't see the components I want on BIM Object, I also go to other content management apps to look for whatever object I want. So for BIM modeling, I use Revit 70% of the time because it's, in my opinion, the most flexible and efficient to use, especially for architecture. And it also has many other capabilities, and it's one of the most interoperable with a lot of softwares, and it has a lot of add-ins that makes the software collaboration so much easier. I use Tekla with bigger and more structurally complex projects for structural modeling, especially with the steelwork, since it's got more steel detailing capability. And it's also very much compatible with Revit. And then I use Dynamo for algorithmic design to automate some tasks in Revit. And for the performance analysis, Revit also has this capability, and sometimes I use Green Building Studio too with Revit. So my go-to software for collaboration is BIM 360. Since if you've noticed, my workflow is almost all Autodesk, so I can have a loyalty award for that. Since, and this makes sure that everything I use is very much interoperable. So that's the easiest to deal with because there won't be any data loss during the collaboration. Also, BIM 360 has great capability, compatibility with other softwares in case a partner is using other softwares for their design. As for BIM validation, Revit also has a built-in BIM validation tool, but if I need to go a little bit deeper and also do some construction scheduling and cost scheduling with the validation, I use Navisworks. Although Revit also has costing tools, so that's a plus. So as for the construction management, I use Navisworks mostly, but for some projects, they call for more scheduling options, for much more detailed scheduling options. Then with that, I use Alice Technologies. And for the facilities management, I advise facility owners to use UBIM, although that's entirely their choice depending on their preference. So this is mostly my softwares of choice. Some just change and get added for the projects and clients that require them. Or sometimes if we need more detailed functionalities, we also go to other softwares. But this is what I'm saying the last lesson. It's better to know the place of softwares in BIM so you know how to mix and match your softwares depending on what you need. So you can expect that these are also the softwares we're going to be learning about in the BIM programs if you decide to push on. Anyway, as you saw, I have a particular bias for Revit, and a lot of you have been asking about my favorite BIM software. So let's talk a bit about it. A lot of people use Revit, but throughout my career, I saw and found out that almost 70% of the users are either using it wrong or not maximizing it entirely. So let's talk more about it. I like using Revit because it's basically multidisciplinary. It has tools for every discipline, from architecture to structural to MEP to construction. And Revit has it, and it has the best interoperability, in my opinion. And they develop tools to expand that further year after year. And it's multifaceted, so you can run Revit for many BIM tasks, for small to medium projects. You won't even need other softwares. It has great value for money too, since you're able to use it for many different tasks. So you save on buying many different softwares for different tasks. It's very efficient. A lot of BIM tasks in one software makes the work easier, since you won't have to switch here and there too much. And it provides great cloud collaboration. Autodesk provides the best options for cloud collaboration, and they have lots of tools that would connect you to the project no matter where you are. And the other thing is, it's one of the easiest to learn, and it's very user friendly and very beginner friendly. So here are some functionalities of Revit in BIM. So one, we can do parametric components from Revit. We can work share, meaning we can all work. For example, we have 10 people all working on one central model. So whenever we work on our local models and update it, it just updates automatically, so it can be seen by the other modelers that's working on that same model. So, and then we have scheduling, the interoperability, and IFC, add-ins. Revit has hundreds of add-ins to choose from, and it's basically different tools that do different things for your software. So it's basically expanded because of the add-ins. And also we have great annotation tools with Revit. And then we have the Dynamo for Revit, where we could do algorithmic design and global parameters. And then we have the design and documentation. We can do design and documentation from Revit. We can do analysis from Revit. We can also render visualizations from Revit. It could also give you the multidiscipline coordination, and it can detail concrete reinforcement as well, and design to steel detailing and workflows. It could also We could also do design documentation and structural analysis. So you could also connect design to detailing, prepare for fabrication. It will give you better communication, and it's really for integrated design. So uh, that's why I choose Revit for BIM. It's also what I use to teach BIM, and along with other softwares I showed a while ago. So let's see a bonus video of how the basics of Revit work. So wait a sec. Okay. So I started by opening a new Revit file and then drawing a property line through Sketch. Now this property line is what I'll be basing my design on. So what I did was I drew some model lines to guide me through the conceptual modeling. I wanted to make a 6 unit apartment, and I wanted to make it simple. I didn't want it to be too complex, but also not looking like a shoebox. So I decided to make six staggered shoeboxes. Just kidding. But yeah, bit like that. So after I'm happy with the basic shapes, I set the levels in the elevation view. Now just a note, in BIM, whenever you make a level line, it also automatically makes the corresponding views. Then, after that, I set the grids using the model lines and the conceptual model as a guide. Now, as with the grids, whenever you place columns or walls that align or that are locked to the grids, those objects will also move with the grid. Anyway, after that, I placed two firewalls that will separate the units, and then now I'm putting in the columns. You also have the option to automatically put the columns where the grids meet, but I like to do it this way for cases when I'm using different sized ones. Then what I did was I made a few model lines to mark where I'll have the bedrooms and the toilet and bath. I like to keep my models clean, so I keep myself from using too many lines. I already have a layout I want in my head, so I just delineated some and directly went for the walls. Now, one thing you need to be reminded of here is when I do the walls and the columns, it's all already in 3D. So I always need to keep that in mind in setting the thicknesses and the heights and other parameters. Anyway, so I modeled the doors in as well. And as I'm modeling the doors, I found that I needed a few adjustments on the grids and the walls. So I did that, and then when I was done, I just copied the doors onto the next other units. So if you can see, Revit already automatically tells me when I have just modeled conflicts with other elements, so I could just really adjust it accordingly. So now that that's done, I went straight to modeling the floors. Now the way to model the floors is by selecting what type or thickness of floor you want and then sketching the boundaries of the room you want to place it on. Now, I'm not focusing too much on the structural sanity of this design as I'm only conceptualizing here. So what I want to end up with is the basic layout and the design that I can use for further design detailing. So once I was done with the floors, I modeled in the stairs that go up to the upper units too. And then I placed the windows in both the lower and the upper units. And then I modeled in some more external floors for access to the second floor and some also for the laundry area at the back. And then I went in and also modeled in some of the railings. Basically, what you'll see is a lot of it is very automated. Maybe like you're playing Sims, if you've ever played that. I play a lot of Sims and it's really right about the same. When you're modeling, just of course. So what's next would be the roof. I started with the basic roof by sketching its slope and elevation view so I can get the exact height I want. You can make roofs in many different ways in Revit. This is just one way. Now, when I was happy with the roof, I realized that it looked a little dull, so I decided to put a facade element. So I modeled the basic form of how I wanted it to look as a conceptual mass. And you don't have to worry because I can use this mask to model the element I want. So I made the adjustments, tried how it looks, and then when I was pretty happy with it, I used that mask to create a roof, which I'll edit to be a thin roofing element. And then I also used it to create curtain wall selections, which I then configured to be trellis by changing the settings and the materials. Now after that, silly me realized the roofing looks bad, so what I did was I decided that I wanted 6 different heights of the roof. So, lower roof for the bedrooms and higher for the living areas on the second floor. So I did that by changing the length of my original roof, duplicating it, and then put the second one higher on top of the living room area. I cleaned it up, copied it onto the next grids, and then I had to once again connect the walls to the roof. Now, it was a bit more complicated this time because I had 6 different roofs. So I just selected my walls one by one to connect it to the roof, and then the columns, and cleaned up the model a bit. Then after that, I figured I really need to fix my firewalls. So I did, and fixed the profile of my walls by sketching how I want it. I did that on 2 of my firewalls, but I also decided I'll just put firewall on the rightmost unit too and adjust my lot. So it looks better, and I have more space near the staircase for landscaping. And I made more adjustments on the model design as I went. Now, if you notice, since we started, I'm focused on the design through all of this. I could try and see what works, what I want. I can change it how I want. I use generic model items for my conceptualization since I only want to focus in on how it will look and function, and I know that I can detail it or change it easier as I go with the design. And I don't have any issue on whether I need to do elevations or floor plans first because as I'm modeling in my 3D and through my floor plans, all of those drawings are also automatically updating already. It gives me more time and focus on what I should really be doing, which is design. And it gives me the chance to work out and try out many different iterations of my idea and find the best one that works. Now, after I'm a bit happy with the exterior, I went on and just detailed the furniture and fixture layouts of the units. Again, I can try out many different things, see what works, change the elements, load in the objects, and just place it in my floor plans. See if it works. Change it if it just doesn't. And I know it's not pretty or too perfect, but it's okay because they're just placeholders for now and I can change them easily anytime. And I also know that since everything is in 3D, when I make a section view, it's all going to reflect there instantly. And actually, the way you make a section view in Revit is simply by placing a section line on your floor plan where you want to cut it, and then it's there. It's pretty useful because you can instantly just see if you made any mistake on the floor plan layout and adjust it accordingly on the section view. Another thing you can do is not just label the rooms, but actually identify a room automatically and place it and automatically detect the wall as room to room boundaries. This room element has area and volume and also detects what objects are inside the rooms. And you can also embed other data on the room element, such as wall finish, ceiling finish, lighting type, number of occupants, etc. So it's really useful in cost scheduling and material specification scheduling. And after that, you can also run solar analysis by selecting your exterior wall, floor, and your roof elements. There are many different types of analysis that you can do in Revit. Solar analysis is just one of those, and even in solar analysis, there are also quite a lot of options and customizations you can do to really dig deep on optimizing your design with the help of the data you get from the analysis you run. Now, after all that, I'm just cleaning up the views and changing settings and putting in the dimensions on different views. What I really appreciate about BIM is the amount of time I save and the chance to do my work better and provide better quality service to my clients because I honestly don't need to dwell much on the paperwork and the tedious manual work needed in the traditional methods. And I can also show my clients visually how the concept looks like. And I can focus on giving more value to my work. And I become more fulfilled and more proud of what I do. And because of that, I get more clients, I earn more, and I have more time for myself and my family. I'm not going to be able to show you more of what I do with just this software, but there's so much more to this. I promise you, what I showed you is just the very tip of the iceberg, and it's quite impossible to really squeeze it into this lesson. And honestly, I've been in this game for such a long time, and I still learn so much every time. There's just so many possibilities, and every year we get new and improved tools that we can explore. All right. So, uh, I know it's not perfect and it needs a little more work and design optioning. And this perspective is not superb, but the thing is, I did all of this in just around 2 hours. And in that time, I now have a concept model I can use for more accurate costing. Since if I wanted to, I can use that model to make a cost schedule easily. And if I'm able to see what different material and I'm able to see what different material choices and form configurations can do to my design. And I'm confident that if I choose to push this design forward, I could just continue detailing this to move to the next design phases up to construction. All right, so I have a question from Alfredo Carretas. Noob here. Is beam placed on this? Oh, yeah. Uh, I think I wasn't able to show it, but you can also model structural elements in Revit itself. You can also model MEP elements on Revit. So just imagine that if I'm able to do this for just a little less than 2 hours, what more can you do if you know what I know and you have more time than I did? So I think after talking for hours in the last lesson and then showing you this, you understood much better in this lesson, uh, which on basically how BIM works. So, inside the architectural drawings, there are many different visual settings in Revit. So you can choose to show structural, architectural, or MEP. But personally, I like modeling them separately and then just linking them together because it's much less cluttery and it's much more clean when you look at it that way. So what I do is I model architectural drawings, design, and then that's for one model, and then I do another model for structural, and then another for mechanical, electrical, plumbing, and fire protection. So in the next lesson, we'll be talking more about the BIM process and the BIM workflow and what your next step is. And you may have learned so much, but our course is really limited, and I'm only able to show you the very surface level of BIM. But I'm sure it now gave you a much clearer understanding of what you need to do to advance and gave you a much clearer insight on whether you want to move forward with it or not. And I know for a fact, as I've experienced, that once you have a much clearer and deeper understanding of BIM and the new technologies and applications, success is really just right around the corner. And you're going to gain the kind of confidence you need to land higher paying jobs and projects. And in order to do that, you would need to keep upgrading yourself. And I'm telling you, every time you take action, you get further faster. And I just want to say that I loved creating these live sessions with you. We've had so many feedbacks and so many people emailing me about their journey in the industry. And it's been so exciting for me to see how everyone is getting this and how big a deal this is and the impact it can make on your life and your profession and what it can do for your future. And it's just been so fantastic. And I love receiving all that email from you. And I love how much you interact with me and how, even though we're all apparently introverts here, how you still find the courage to take action and tell me about how these lessons made an impact for you or what I can do more to help you out. And that is why I'm so very excited to tell you that I've put together a very new training program if you're ready to go deeper. So I've created this basically as a next step for this journey. This is a very different and upgraded program compared to what we usually give. And in the next video, after we discuss the lesson, I'm going to be sharing everything about it and how to go even deeper through that program and what it's about. Although I decided that I needed it to be very limited because I want to be very hands on with you on this one. And it's going to be very interactive. So I'm not going to have much of myself to spread out. So I want it uh, to be very private class. So I'm only going to be taking on a very limited number of students who really want to go deeper. So there's only uh, that limited window to jump in and register. So I'm only going to be opening the registration period for a very short time. So if you're ready to move forward and if you're ready to really master this area, to really change your life, to transform your career, then I'm so excited to share this program with you. And I've been working on this day and night for months now for you because I wanted it to be great. And I'm so excited that I'm finally sharing that with you on my next video. I'll be opening up the course next Tuesday along with our last lesson. And I'll have very limited seats on this, so be on the lookout for that email. Right now, I want to thank you for listening to me so attentively, but I want to apologize since I won't be able to host our live Q&A today because I'm not feeling too well. But definitely still send in your questions and I'll be hosting the live Q&A on our last lesson on Tuesday to answer them all. And I know you have lots of questions, and if you're shy to send them here, do send it via email. I'm really gonna answer everything on our last lesson. But what I will be doing right now is I'm going to be leaving you with a question. I mean, you've been asking me why, despite all of the benefits of pursuing BIM, a lot are still not willing to move forward. Well, let me throw it back at you. Because me, I'm already here and I know exactly why I pursued BIM. But you, what do you think? Why, despite all the benefits of BIM, are you not moving forward? What's your greatest obstacle? What do you think keeps you from pushing forward and switching to BIM or learning the latest tech advancements in the industry? I want to know so I can help you out. And I want you to think clearly about that and send me your answers on the comments below this video, not the live chat, or via email if you're shy. So for now, I want to really thank you for being such a great audience. And I'm really sorry that I won't be able to host the live Q&A right now, but I am noting down all of your questions and I will be answering everything on our next lesson on Tuesday. So I will be seeing you on the next lesson on Tuesday, October 15th, same time. And see you there. And don't forget to send me your answers to the question and your questions so I can answer them on our next lesson. Thank you so much. And I'm really sorry if I have to end this very early right now. So thank you so much. See you on Tuesday.